Okay. Well, I guess we're on. Hey, folks. Uh, thanks for hanging out. Welcome to the deep dive webinar with SBCU USA. If you are new to this, well, it's exactly that. It's a deep dive. We pick a topic every week. We go in. We learn a little bit more. We uncover the little kernels of truth that may have been lost in time. This week, I'm super excited to talk about FSR. The legacy of the adaptations, the trials and tribulations, everything that we have learned in sticking with a tried and true design for a long period of time. I'm joined today. I'm really excited to introduce Jason Chamberlain, the czar of FSR. He's been with us a
Hi
very
there.
long time. And the one and only Mike McAndrews. Mick, big time. You go by many monikers, but we'll stick with big time today. Thank you so much. You are the suspension guru, and the two of you have worked together, whether it's Specialized or otherwise, for a long time. And I'm super thrilled to be able to talk with you guys. So
Thank you.
again, we're talking about FSR. We've been implementing this design, Jason. I think we talked about this since we can comfortably say 94. I think I saw some pictures, really 93 was the first version
Yeah.
and when we're talking about FSR, and we're really starting from the beginning and talking about the legacy, I think we'd be remiss to not mention one name, Horst Leitner, right?
Sure,
So
of course.
Jason, could you tell me a little bit more about him and his involvement to really get this whole thing started?
Sure. I started Specialized about the time we were using FSR and then bought the patent from Horst Leitner. And Mick, did you know Horst Leitner from motorcycle days before he dabbled in the bike industry?
Yeah, for sure. Because I came into the bicycle industry in the early 90s from the motorcycle industry, and I had been involved with Kawasaki Racing and Fox and some other people in those days. That's where I first met Horst Leitner. Horst was a gentleman who moved over from Austria, just this really brilliant inventor kind of guy, and he had done kind of a version of his 4-bar linkage system to put on motocross bikes, and he was same type of thing. He was trying to eliminate the engine torque from the suspension system. And, it was interesting. It did that, but it wasn't really an advantage for off-road motorcycles, but he stayed at it. And really, as mountain bikes started to evolve and he started putting suspension on them, that methodology, that system that he had designed worked really well for the things that were important for this application.
Yeah, it was really far more conducive to bicycles than it was to motorcycles. And the engineers that Specialized at the time adopted it and started digging in how to make it work on a bicycle. And I was in the test lab at the time doing a lot of analysis and breaking the designs they were working on. But it was a great concept and a great design from the beginning, and we've stuck with it ever since the 90s.
Yeah, what an incredible history. And at that point in time, Jason, what did we kind of know or not know about suspension design at that time in the mountain bike world?
Well, we knew that we wanted the suspension to work, to move, to be active, which is what a hardtail was not. A hardtail was super rigid, and we needed to do on the back of the bike what forks had done for the front of the bike, was to allow you to ride over rougher terrain, harder terrain, and to be fresher and have more control. So that's what we were looking for from suspension designs back then.
Got it. But Mick, where were we on the suspension side of things in those early days when Jason and the engineering team and the bike manufacturers were pushing the envelope and seeking some travel, some suspension that moved, but where was the shock technology to meet at that point?
It's kind of funny because, as I mentioned, I came over from the motorcycle industry in the early 90s to actually join a good of mine, Paul Turner, who started RockShox, and the other founder of RockShox was a guy named Steve Simon. And all of us had grown up racing motocross in Northern California and were involved in the motor sport at a professional level. And, Simon's designing shocks and forks for Fox and then himself, and Paul, being factory Honda mechanic, I was doing factory Kawasaki stuff. But what was interesting is we had a lot of knowledge about motorcycle suspension technology and brought that over. But what was interesting is the application of putting suspension components onto a mountain bike, a human powered vehicle, had its own challenges. And so we brought over a lot of knowledge, and we could use that for just like manipulating oil flow, but the application is so unique because it's a human powered vehicle. To Jason's point, we wanted to get that suspension on there so that we could isolate trail events from the mass, the rolling mass, so that it was efficient and improved control and traction and all that stuff. But just the damping characteristic, what we were trying to do with springs and damping and everything was so unique compared to what we had done on motorcycles. So the early days, the biggest challenge we had was just not a lot of wheel travel. And I think everybody was kind of coming over from road bikes or hardtails. So any kind of suspension movement that was zapping your energy was just not acceptable. So a lot of focus on frame kinematics, the FSR system to isolate those, but also damping and spring curves and shapes that you wouldn't find in other applications, so that the bike had that snap or that feel that you need on a human powered bike.
Absolutely. Now might be a good opportunity to, let me just share a screen and some conversation here. Can you guys see this? This I think one of the first FSRs, and with the coil on the back there. And you know what, I've got another photo here of the frame. Now, Jason, I think you sent me this. Looks like it was copied or Xeroxed from a magazine here, but this.
Yeah, from our catalog, it sure was.
Perfect. Now, I really like this, because this, well, one, it's got a Fox Air shock on the back of it, and I think this is 1994. I honestly, before seeing this, did not know that we were running air shocks all the way back in these days.
Yeah, look at the diameter of that piston, and the chrome shaft is right off of motorsports.
Right, it's huge. And something else, now that this is just stripped down to a frame, what I'm looking at here is I'm kind of taking in the pivot placement here. And Jason, I'd like to pick your brain a little bit on these early days and what we were solving for. What were the ride characteristics? What were riders doing on these bikes that informed the engineer's decision-making process on how the kinematics worked on this bike? And I'm looking at that main pivot. By today's standards, looks really low and pretty far back in relation to the bottom bracket. And also the location of that horse pivot, that horse link on the chainstays in relation to the dropout. So could you talk a little bit about what drove that design?
Sure. The beauty of FSR is that it's very versatile and very flexible. And the term 4-bar comes from textbook engineering, where you have 4 pivots and 4 bars. And the key is that your wheel is attached to a bar that's isolated from the front triangle by 2 links. And when you do that, you're able to do math calculations about how the rear wheel and that bar it's attached to interacts with the front triangle. And you've actually got quite a bit of flexibility on where you put your pivots. In this case, the shock was so short, you could package it behind the seat tube. Other designs, we package shocks all over the place now, but still at the heart, you've got 4 bars and 4 pivots and 4 links. One of the hallmark features, of course, is the horse pivot, which is close to the dropout. But even still, you've got quite a bit of range where you can put that near the dropout and get whatever results you want.
Okay. Yeah. So I get that. And taking that and understanding the versatility of that design, sort of the beauty of that, has allowed us to adapt and evolve over time and continue to tweak as, of course, the sport has changed a lot. And this might take us into the late 90s, where the initial boom of mountain biking has certainly, it's full swing. We've got a younger riders, new generation that's hopped on, and you know, that would have still realistically been before my time. But you guys were working on this stuff. You were designing products, and you're really in the thick of it. And also, you know, you were the drivers of this change, right? I mean, at this time, Mick, I don't know if you were in Santa Cruz at the time, but you know, you both were riders. Jason, you had mentioned to me the type of riding that you like to do is stopping and sessioning trails and hitting jumps and doing things, and that kind of pushes it pretty far from the early days of what mountain biking was, right? And could you speak a little bit more about what it was in the early days, and where it became, at least in the late 90s, when we're looking at something like you know, an FSR XC or an early enduro, which I've got right here.
Yes, of course. In the early 90s, you had hardtails and full suspension bikes. That was it. In the late 90s, the suspension bikes started to branch out into different focuses. The FSR XC was one of the first ultra lightweight, short travel full suspension bikes. And then the longer travel bikes, there was actually an enduro model bike in, I think, 99. And so for people that didn't want a super light cross country bike like myself, I like to stop and ride logs, do drops, session things along the trail. I wasn't concerned with going as fast as possible up and down. So different riders had different preferences, and they kind of moved towards XC or trail or enduro. Longer travel bikes started to merge at that time. And it was a really exciting time because you just started being able to design really focused bikes for focused riders.
Sure. And at that point, travel is starting to come up. We're seeing some more complex designs, increased demand from riders. Mick, at this point, in sort of our evolution of mountain biking as well as FSR and everything in between, what was that climate like for you at that point in time?
Well, you know, on the damping or shock absorber technology development, just as a general within the industry, because what was happening was, I mean, as you guys had stated, I mean, early on there was cross country racing, and if it had suspension, it was downhill racing, right? It was like these two extremes, because these downhill bikes, you couldn't really pedal up the hill. They weren't efficient for pedaling. So if you were going to do that all day out and back and those epic rides, you did it on a hardtail. And as you know, we've discussed before, it's kind of, it wasn't like really riding a section of trail over and over again. I mean, you were just doing these long rides, and you know, just the terrain wasn't really a lot of fun. It was more about just getting through the woods and things like that. And then if you had a bike with suspension, boom, you got hauled to the top of the hill and dropped off. And so all through the 90s, it was all about the way people were really riding. You know, you wanted to ride to the top, and then you wanted that really bitchin' ride to the bottom, that flow. And so what was happening is we were making these bikes in the middle where it was an enduro or a longer travel stumpy that was really feeding into that. And the other thing that was happening too, that having grown up here in Santa Cruz, you know, riding all up on campus, Highway 9 and stuff, I remember the trails we rode up there. I then did a stint back east where I was living in New England for about 5 years. And when I came out, the trail system was totally different. It was an area that I've known since I was a kid, but you could see that the way people were riding the trails, you know, there was like a trail that would get you to the top, and then there was 20 descents, right, of just these bitch and flowy trails. And so the bikes, I don't know which came first, chicken or the egg, the trail building that the young generation was doing, and then the bikes were being designed for that type of riding. You know, there was a whole shift in who the consumer was and how they were riding, and then we were doing it with the bikes. On the suspension side, because air spring technology is something that we as an industry, the bicycle industry, has embraced and put a lot of effort into developing that technology, more so than motorsports of any kind, cars, motorcycles, whatever it is. They've all played around with it, but it was too complicated. You couldn't get this right spring curve, so they dumped it. But it was so important for us as an industry because it's lightweight. It's infinitely adjustable for the most part at the consumer level. You're not having, we've all done that coil spring thing before. I love the coil spring, don't get me wrong, but the usability is an issue. So in the 90s, it was all about getting the longer travel, but all of a sudden the challenges of the air spring and that the funky curve that it does, a lot of technology on how we would manipulate those curves to give us something that was a little more linear, like a coil spring. So we didn't have weight advantage and that adjustability advantage, but also started manipulating that curve so it would behave like we needed it to through the longer travel. Then there's also damping curves, and as we started getting longer travel, we could actually use multi-circuit systems, meaning we would have low speed, mid speed, high speed circuits that we could tune independently, which is something that we were very familiar with from the motorcycle stuff, you know, the motocross bikes and technologies, because they have that long travel, the big piston speed that the bicycle space didn't have before that. Those early designs, that was the biggest challenge, because you had short wheel travel and short shock travel. All I could do was just basically very little on compression and then just control the spring on rebound.
Yeah.
With FSR, we used to advertise vertical wheel path. And when you only had 70 millimeters of travel, your wheel path was mostly vertical. But when you're up at 170 millimeters of travel, you know, double that or more, you've got to really understand your wheel path and how that interacts with the shock much more particularly than you had to in the early days when you only had a couple inches of travel.
Right, absolutely. And, you know, Jason, I'm glad you mentioned that, because as a younger guy, you know, back then, I very clearly recall the messaging of the wheel path, and speaking to the FSR had the vertical wheel path, and it seemed that by and large that's what the mountain bike industry was chasing at that point, was at all costs eliminating any growth of the chain length, and it was all about avoiding pedal kickback at that point in time. Nowadays, obviously, it's a much different story. You know, we are touting rearward axle path, say on the new Enduro or the demo and things of the sort. Now, that is nothing necessarily new now. You know, understanding that seems to have kind of fallen in between the late 90s and where we are today. But yeah, again, Mick, is kind of, you said it, the chicken or the egg sort of scenario. At the time when we were really designing for a vertical wheel path, was that representative of the type of riding that we were generally doing, where trails were less manicured? Maybe it was a little bit more raw backcountry, and we needed to just be able to pedal away through everything, and we really didn't want to deal with any kickback? Or were there other things that were informing our thought process at that point in time?
To Jason?
That's to Jason, yeah.
Oh, I thought I heard Mick in there. Sorry.
Oh, sorry.
Yeah, the wheel path is important, and like I said, as the travel gets longer, you still have the same expectations from your bike that it's going to be efficient. So as the travel grows, I mean, even our Epics have 110 millimeters of travel, which is almost what downhill bikes had in the 90s. So even that's considered a lot of travel by those standards. And you have to pay careful attention to all the variables. You've got your anti-rise for braking, your anti-squat for pedaling, wheel path, chain growth is a function in there. All those things have to be balanced, much more particularly now because of the longer travel, but also because riders are a little bit more discerning, and riding has advanced to the point where riders are so smart now and so knowledgeable and have a much better understanding of how to tune their bikes and how their bikes should feel, that you've really got to be on your game and understand what the rider wants. And every couple of years, when we introduce a new bike, we do a huge research project to understand where are we today, how are people riding, and what nuances do we need to capture with the next bike.
Sure, it's always a moving target, and I imagine, yeah, Mick.
Oh, I was going to add on that, because Jason hit on a good point, I think, earlier leading up to that, because I think you were talking about wheel path and how that was such an important message back in the day. And it really was short travel by today's comparison, but they weren't so short travel. 70 and 80 millimeters was considered long travel back in the day. But if you think about the pedal zone, you know, when we look at suspension, rear suspension, especially when it's longer, you know, there's ride height, there's bump zone, there's ending of the travel, and we kind of look at what we're trying, how we manage that travel for the overall ride. And so that, you know, that vertical wheel path, it's still really important to control what the wheel is doing in the relationship in that pedal zone. But you know, you're deep into the stroke and towards the end of the stroke, if the wheel is coming forward, you try to minimize that because of other issues. But on that pedal efficiency, these guys still pay a lot of attention to what's going on in that zone of the travel where you're pedaling, because it wouldn't make a lot of sense deep in the stroke to worry about it, because I'm sure it could happen where you'd be pedaling along and be at the end of 180, but it's not designed.
Yeah, that's highly unlikely, I'm sure. Now, you know, you guys both kind of touched on a few great points that I think are an excellent segue into sort of our next chapter, our next era, being early 2000s, and what the heck was going on with the riding scene. How were the riders continuing to divide into different factions, and how was FSR and suspension technology both kind of going with that and staying with it. So I've got another few gems to share here. So this is, I think both of these are going to be representative of about the 2002, 2003-ish time frame.
Yeah, that's correct.
Yeah. And, you know, gosh, where do we start? I think, you know, with all the talk about efficiency and what we were looking for at that point, why don't we dig into this epic and the still radical, I think now, but extremely so at the time, Sidewinder frame.
Sure. So I was the engineer on that frame, and at that time Mick was doing a short stint away from Specialized at Fox, and Bob Fox was really passionate about figuring out this inertia valve with the help of Mick, and the two of them were working on the shock side, and I was working on where to put it in the frame. And so that epic really was revolutionary in that it had two modes that worked automatically. It's either mostly locked out for standing and sprinting, and or open when you're in the bumps. And Mick can certainly talk about how tricky that was to pull off from the damper side.
Yeah, tell us a little bit more about the early days of really pioneering this thing.
Well, you know, you had a slide earlier where you showed that Enduro and that FSR XC.
Mm-hmm.
And that FSR XC was a bike that we were really keen on. We were really excited. That was a great bike when it was introduced. And it was a lightweight, full suspension bike. And Mike Senior was really keen on having our cross-country team race that bike. And so I was sent on a journey. It's the bike to the left there. And really, really, really a good bike first time. So I went to Mallorca, Spain for the downhill, or excuse me, the team camp. They were there for 2 weeks training and stuff. And so my mission was to get over there, run some controlled tests with them to show them that full suspension could be faster than a hardtail. And so I set up all the testing. We had all the, you know, the traps set, the start, the stop. I was showing them, you know, boy, and all of them were faster on full suspension through this stuff. And you know, and then at the end of it, so I said, okay, are you guys going to race it? Because that was why Mike sent me over there, make sure to get these guys to buy into this. And one of the Italian guys, he's going, no, he says, yes, it's faster on this, but when I sprint, it feels like I'm running on a mattress. He said, I can't run on a mattress. I can't race it, right? And so, you know, head down, I had to get on the plane and fly home to California to tell Mike that I was unsuccessful. And, you know, there's that saying about
yeah, that's a long,
necessity.
hard trip.
Necessity is the mother of invention, right? On that long flight home, I kid you not, and I probably should have had him for this, I hand sketched the design for the inertia valve shock absorber because, you know, the inertia valve there were people that played around with this in the automotive industry, and a friend of mine was an engineer at Ford, had told me about the whole concept years ago. And I thought that's what I need. That knows, firm from the top and soft from the bottom. And so that plane ride home, I penned that out. So, when I meet with Mike, it's kind of good news, bad news. Mike, bad news is they're not going to race it. Good news, I think I have an idea for a technology that will get them to race it in the future. And that's how that thing was born.
That is remarkable. So, Jason, on your end, when you're sort of tasked with this and you see what Mick has going on with this thing, what's going on in your head, and how do we work around these challenges?
Well, in the case of the Epic, we worked very closely with Mick and Fox to get this thing built, and we do that all the time with our suspension partners. Sometimes in the past we've built our own suspension. Other times we've gotten it through a partnership with the vendor, whether it's Fox or RockShox or Oleans or Progressive Suspension. We've had a lot of partnerships over the years, and it's critical that it gets integrated into the frame properly. The Epic, for example, is the brain has to be, the inertia valve has to be backed by the rear wheel to work best. So how do I get a shock in that area? The Sidewinder was a logical way to do it. So you've got to work very closely with your partners to make sure those are integrated right.
Sure. And this is not necessarily suspension related, but what was the urgency for having 2 water bottle cages on that Epic? Was that a significant design consideration?
It was, for sure. People drink a lot of water, and nobody else had a cross-country bike with 2 water bottles at the time that I can remember. And so the product managers, they give us a list of their hopes and dreams, and then as engineers, we try to execute it. So keeping 2 water bottles in the front triangle was absolutely a goal on that bike. I think it's even written in the patent. And we definitely keep 1 water bottle on all of our other bikes. So it's a big deal.
Yeah.
Absolutely.
And I'm not even sure hydration packs were around back then, were they?
Well, you certainly weren't going to race with one, and you weren't going to refuel on a World Cup circuit with one. So
no, there wasn't too many of them around, so you had to have those 2 water bottles. That was the list.
Yeah. And then I'm curious, when looking at these side by side from a suspension engineering standpoint and knowing the needs of the specific rider, how does that inform your design process, Jason, when say you're looking to build up this Epic versus this, at the time pretty wild enduro, with different travel, different needs, I would imagine inherently different ride characteristics that you're looking to squeak out for the rider?
yeah, jumping over to the enduro, which was the opposite end of our spectrum at that time, it was a long travel bike, and you've got to package the wheels in a long travel package. And yeah, that one right there. Maybe I'll take you on a quick glance at my garage, because I have on my, where are we?
Let's see the museum here.
Oh, there we go. All right. So I keep a sample of all the frames I've worked on. And these are pretty much all frames I've ridden. So here, right there, you can see this gray anodized enduro was one of my very favorites. And actually, I got 2 of them.
Yeah. Is that a Fifth Element air shock I see on there?
Yeah. Got the Fifth Element air shock, which was one of the very first high volume air shocks that people hadn't really thought about yet. And of course, I've got all the enduros up to the current ones. And I've even got the first hardtail I designed, which then came into the Epic. And I designed a carbon hardtail in my day. And anyway, we'll maybe jump back to a couple other bikes as we go along here.
Absolutely.
You probably want to mention the itch switch, which was pretty revolutionary for its day, that was on that enduro. The itch switch was on the 2002 Enduro was basically two modes, a long travel mode and a short travel mode. And in principle, it was very easy. Again, this is when we partnered with Fox, and uh, Mick was at Fox at the time, and he can tell the story from his point of view. But myself and Brandon Sloan, we really wanted a long travel enduro that had a short travel mode for climbing. And we just wanted a simple switch, change from long to short. Mick, you figured it out. That's what we want. And at the time, Mick was kind of against the idea. Why would anybody want two modes? I mean, a climbing mode, a descending mode. I'm not sure it's a feature people really want, but we talked him into doing it. And Fox did a great job of figuring out how to do it. It was all done with the air spring, and it was a very simple lever that switched between, I think it was 4 inches and 5.2 inches of travel. And it was really a great feature on that bike. Mick, you remember that one?
Yeah, I remember it well, dude. Because he's right. I was at Fox at this time, running the bike division with Bob Fox, and we had a meeting with Jason and Brandon, our two favorite guys down the road. You know, we're in San Jose, they're in Morgan Hill, and so they present this idea that where they want to, you know, two modes, two travel modes, and I'm thinking, okay, you got long travel, short travel, because if you're not going to have the advantages of long travel, you kind of want a lower center of gravity for better cornering. And they were saying, no, we want this thing to be long travel, and then you flip it, and it's short travel at the top part of the stroke, because they wanted the chassis control for climbing and just more efficient in the pedaling. And that's where I was like, I don't get it, guys. If you're going to go shorter travel, drop it, right? And they're like, no, we want this for the again, trying to get these long travel bikes to climb. So I wasn't a big fan of this in the beginning, but once we got it, you know, in prototype stage, got out and test and proved the concept, they were spot on with what they were thinking. And this was the beauty of Bob Fox. I mean, he loved engineering challenges. In this particular case, they didn't really come in with a technology per se on how to do it. This is what we want out of the shock absorber. And so Bob came up with this itch switch idea where basically you had an air spring and a secondary volume chamber, and then the switch would either give you a small volume or bigger volume. And I think Fox is later, you know, 10, 15 years later from what we did on that itch switch, but that was some forward thinking. And he teases me all the time about that. But,
yeah, the naysayer.
The one time I was right.
Well, you know, hats off to you and Sloan. I mean, you guys clearly had a vision. You knew in that vision may or may not have been pretty well ahead of the curve of the industry at the time, but you had it. And well, I think at this point, looking back, we could say you were absolutely ahead of the time, because to your point, Mick, 10, 15 plus years later, Fox is still implementing that. I could think of a few brands that won't be mentioned that maybe are close to where you were living on the East Coast that had some version of that not so long ago. But, you know, that was a groundbreaking product. And Jason, that version of the Enduro, I think you were telling me that won like a Bike of the Decade award somewhere.
Yeah, there was a British magazine that awarded a Bike of the Decade, which was one of the biggest honors I've ever seen us receive, because the bike was probably 8 years old by the time they wrote that article at the end of the 2000s, and to have that still be in people's mind and still be fresh and still be remembered as such a great bike was just a huge compliment to the whole platform.
Sure. And you know, it didn't stop with Mick being able to pull off the itch switch, with you and Sloan driving that advancement to create that all mountain thing. I mean, it visually was striking, and implemented some pretty forward thinking technology just to manufacture the thing, right? I mean, at that point in the early 2000s, that big monocoque construction, there were no real big players in the industry such as ourselves that were implementing that. That looked like a bougie sort of boutique, you know, one or twosies, small operation construction methods. So again, on the engineering side, to really pull off the whole package, what were you up against with that?
Yeah, those monocoque frames, they were easy to do in small quantities. That's why some of the boutique brands were doing it. You could make your own rubber mold and form the sheet metal yourself, but to do it at more production quality quantities that Specialized needed, it was harder to do. So we found some suppliers in Taiwan that did sheet metal, and we taught them how we want it done on our bike. And we made some real big sheet metal formings on the Enduro, on the Big Hit, on some other bikes. And they were really beautiful bikes for the day. And one of the things that we brought to the table was robot welding, where the seam, where you're taking two halves and welding together, you have to weld across that whole seam. And with the human welder, he has to weld, move his hand, weld, move his hand, weld, and they have to readjust his or her hand the whole time. Whereas with a robot, it can make one continuous bead start to end, and the weld bead just looks absolutely beautiful. And people were really particular to the look of the weld beads on their bikes back then. So I think we did a really interesting job with the monocoque bikes we were able to deliver back then.
Yeah, no, absolutely. And, you know, talking, it sort of makes me a little nostalgic, honestly, just even thinking about admiring a weld bead. You know, it's one of the kind of just, it falls away slowly in the world of new, smooth, beautifully sculpted carbon frames, which are great. But, you know, yeah, now that you mention it, that I do kind of miss being able to really, really lock in on a weld and admire that. But moving forward from there, we've got some exciting stuff, you know, kind of taking us from the early 2000s kind of into the mid 2000s. And I'm going to share something here that that might spark some conversation. So this, I think, is kind of taking us into 2004 to, you know, 5, 6
Yeah,
thereabout. And so we're looking on the left, I'll refer to as sort of a shock tunnel era that we went
yeah,
to. We started seeing a lot of these designs. Um, and it also looks like that starts to kind of be the emergence of some form of larger air springs on our air shocks at this point. So, Mick, before we dive into the pretty wild demo 9 here, which Jason, I'm sure you have a lot to talk about, Mick, let's talk a little bit about, you know, what was happening with the suspension world at this point in time. Jason previously had mentioned that progressive fifth element air with the large air volume, that was really one of the first. And at that point in time, I don't think the industry really knew what to make of it, why it was necessarily better. But it did catch on. We're certainly there now. What was that like in the early days?
This was really, I love these photos that you found, but for sure, around this time, I was talking about it earlier, air spring technology and how important it was. And you can start seeing it time on that shock. You start seeing bulge or more volume at the end of the air sleeve. That's your ending volume. And then a lot of the makers of air shocks at this time were doing more on the negative side as well. And so negative air spring, you can't really see. You hear about it, you know something's in it, or the negative, positive, all that stuff. But it's an opposing chamber that helps take the nose off the beginning part of the air. So it goes deeper into the travel, behaving like a coil spring would. And then the main compression of the air volume is what gives us the spring rate across the middle. And then the ending volume, or the compression ratio, how much volume is left over when the air piston stops, that volume right there has an effect on how steep the spring climbs. And so this was that era where the shock makers, in particular Fox, doing a lot with negative air springs and then that ending volume to give that spring curve the shape that's needed for these longer travel applications.
I see. And Jason, at this point in time now, with the suspension world sort of making some changes, some adaptations, we're seeing those different spring curves. Did that have any impact on your side of this equation in how you're engineering the kinematics of these bikes.
Yeah, the kind of what I was saying is you have to partner with your shock maker so you get the air volumes matched to the kinematics of the suspension. And back in the early days, shock makers would offer you one size of air spring. Now they've got multiple sizes of air springs with multiple chips on the inside so the consumer can adjust it. So now, after going from way too small a volume to probably too much volume, now we're somewhere in the middle with a lot of adjustments. So we could really dial in exactly the air spring you want for a particular frame.
Sure. And now kind of when we're talking about dialing that in really tightly, could you tell us a little bit about the Demo 9? And maybe we'll spend a little time talking about 6-bar. How and why?
Sure. The Demo 9 is one of my favorite bikes. Maybe you can, if anybody remembers what the tagline for our ad was back then, leave it in the comments and we'll see if you're right. But I have one of the frames right here. The Demo 9 was beautiful. It was just so big and burly and crazy. And it led to some other bikes like the Demo 7, and that evolved into the race bike, the Demo 8, and on down the line. The original Demo 9 was still a 4-bar bike, but it was a very complicated looking bike. And I wouldn't confuse that with the current bike, the current Demo and Enduro, which is a 6-bar bike, where you actually do have 2 extra pivots here and here, which drive the shock. And so you've still got your 4 bars, which drive the braking and pedaling, and you can separate what the shock does from what the rider and the kinematics of the frame does. And that's kind of the purpose of the 6-bar. But that original Demo 9 was such a great bike because it was just way over the top for its day. And I actually loved that bike.
Absolutely. Yes. I mean, over the top might be an understatement. You know, it's also nothing necessarily new to us. We kind of make a habit of it. But what were we really solving for in creating that?
On the Demo 9, it was a free ride bike, so it had to be super strong. And it had to have a lot of travel, because remember, this is the early days of free ride where people were trying to see how big they could huck. And I remember when journalists would come into Morgan Hill, they'd land at the airport in San Jose, drive down to Morgan Hill. Along the way, there's these hills on the side of the road, and everyone would talk about, oh, you think I could huck that over there? I think I could huck that? And everyone's looking at these features on the side of the road to see if they could huck them or not. And that was what people were looking to do, places to jump their bike off, cliffs to drop their bikes off of. And the Demo 9 with 9 inches of travel was just huge. And putting the shock down low so that all the weight was central and low was for handling characteristics, and also allow you to drop the seat post as low as possible. Because believe it or not, those free ride bikes, for the most part, guys still had to pedal those up the hill. So we actually wanted a bike that you could drop your seat post for the hucks, but still raise it up high enough, which was kind of a theme in that whole period. You mentioned shock tunnel bikes earlier. That was a big deal, trying to raise your seat up and down on bikes, and that led to a lot of innovation.
Sure. I mean, we didn't have, obviously this was just a little bit ahead of the curve of a height adjustable seat posts, or I mean, at least as we know them today, a telescoping version of it.
Absolutely.
You know, let's not get into height right and all of that. But, you know, that's actually a great segue into kind of what I would imagine it would be the next generation of FSR bikes that we had. And as I understand, you know, here we are. So this will just touch on briefly the rocker link era. You know, what were we solving for here? As I understand, this really again speaks to we need more ability to drop to move our seat posts around. We wanted to get back to an uninterrupted seat tube.
Yeah, there's only a couple of ways to get out of the way of the seat post. And one of them is a rocker bike, and one of them is a shock extension bike, which we'll get to after this generation. But these rocker bikes did exactly that. You can run your seat post right down past that linkage and slam your post as low as you want. And that was the goal. The drawback was there were a lot of rocker bikes on the market that day, and it just didn't feel as authentic and as specialized, and we thought we could do better. So we moved away from the rocker style bikes after just a couple of years.
Yeah, but however, kind of in that time frame of the rocker link bike, there were some pretty exciting advancements being made overall outside of just the aesthetics of the frame. And I think those things, maybe Mick, you could speak to a little bit more clearly, because on that bike I saw a Future Shock fork, I saw a Specialized shock on there, and would that
There's a brain on that bike too.
And a brain, yeah, we used the brain everywhere at that point in time. Could you tell us a little bit more about that process and how we started integrating the suspension technology into our platforms even more at that point?
Yeah. Mike and I, it was probably around 2003, 2004 is when we started this conversation. Having, again, as we had spoke about earlier in this conversation, I had worked at Specialized as head of the engineering group at that time, a small engineering group, and then also was over in the early days at RockShox helping run their advanced R&D group, their engineering group, and then back at division. So I'd seen the dilemma, the inventor's dilemma within our space from both sides. And Mike and I think we were at Interbike and we had breakfast one morning and we were just brainstorming and that whole concept of being able to, as a bike company, you have a vision that you develop within your product team on what you want your product to do, but to be able to have more control of the entire process of all the components and everything that help you get there was the idea. And so out of that, he convinced me to come off that mountain in Vermont and come back out to California. And this would have been towards the end of 2004, I believe. And that's what we launched, kind of our internal suspension program, which I still, run today. And at that time, we were thinking, okay, we're going to do forks, shocks, whatever it is to get the technology and stuff that we wanted. And a lot of times, because you go into the suspension makers, and although they want to work with you, they're hindered on what they can do because they've got to design a bunch of product for the masses, and they've got to get it out there. So a lot of times, you're not going to get exactly what you need. So we said, to heck with it, we're going to do it. And we did it. And we were doing forks, shocks, and we were coming up. I mean, we did some stuff, on those forks. I mean, we did the first tapered steer tubes, carbon fiber steer tubes, so to get that to work. We did a single-sided fork, which I still think today would rock. I mean, we dumped everything on one side; the other side was empty. You could look down it, and there was nothing there, right? You just put everything over there. Super efficient. We came up with even non-brain technology and how we managed fluid flow. We were big on kind of these square damping curves for these light vehicles. So we were pioneering a lot of that stuff. Spike valve was a technology that we came up with and patented. We still use that today, and even other people's product that we do our RX tune with. So we drove it, but it was that holistic, we're going to design the whole thing together. But, it quickly became, problematic in that it was too big a project. We weren't really a suspension company, but we became one overnight. And a lot of those innovative ideas, unfortunately, because, I've been in the industry a long time driving stuff, whether it was a Fox or RockShox, but when it was branded as Specialized product, a lot of people just didn't realize the investment that Mike had made for this internal team to be able to do it at the highest level. And it just never really carried the cachet that Fox or RockShox or Manitou or somebody of the day would have. So what we did was we continued to morph that. The vision, we never lost sight of that because we understood the value of making better bikes. And so we just, over the years, we've kind of evolved that into the program that we have today, which we still will drive design initiatives like we do with the current Epics and Brain. We will drive that and advance that technology, but also through our RX Tune program, same thing. We own the final tune and setup, and we go deep into how we do that. And this is all started from those bikes that you see there, where we were doing. It was really fun because we would design the shock and the airspring and everything with the frame engineer, right? So that volume, that compression ratio of that airspring was dialed for the wheel rate of that bike. That was the only bike it went on. We didn't have to have a big air sleeve with a spring curve that could take care of everybody's bike. We just focused on that, and then we do the same thing on the fork, and we make sure everything is balanced. And so that was really the nugget of success there. And then worked it into a program where we don't have to be the maker. We've got strong partners with Fox Rock Shocks that respect our program and allow us some freedom to help drive the product that we spec, so that we maintain that vision that the PMs want.
Absolutely.
So that's how that started with those bikes.
Yeah, that's an incredible story, and I love, as you say, that we never lost track of the overall vision, you know, and you and your team have been able to just adapt and sort of evolve that and tailor it into the most practical way possible to still continue to achieve it. And moving on kind of from that, you know, Jason, you talked about the Clevis style bikes, which, you know, more or less is that's what we know today. That kind of takes us to the present. But along between then and now, there were a lot of things that did change, and some things that you needed to adapt to. So I've got, you know, one of these early Clevis, I believe Stumpy's here with the brain on it, and what I see looks like an integrated front derailleur mount. The location of that main pivot is not sitting behind the bottom bracket anymore. That's moved up quite a bit, moved forward a lot. The placement of that horse link has changed quite a bit from some of these earlier versions. You know, so the overall layout has changed. My question to you is, what was driving these changes? Is it wheel size, needing to adapt geometry, simply accommodating for more travel? Can you tell me a little bit more about that?
Sure, there could be a lot of reasons. For example, the main pivot on this bike, we wanted to be closer to the front derailleur so that we could mount the front derailleur right to that main pivot. So a lot of times you can move a pivot 10 millimeters one way or another, and you can do something else with that pivot as well. And you can achieve better stiffness, better, you know, narrower, wider, more compact, more stiff. So like I said before, the FSR is so flexible. You've got a pretty wide range of where you put your pivots for whatever reasons you need, and still keep the heart of the bike, the performance of the kinematics in line. And so you mentioned the shock extension bikes. What I liked about the shock extension, that was our solution to shock tunnel bikes. And if you can see this orange bike right here, it's my sample of a shock tunnel. So you can see that your seat post is not going to go down very far before it hits the shock. And we used to have people slamming their seat posts and damaging shocks all the time, and it just wasn't very elegant.
I remember some adhesive little rubber blocks that we used to ship you know, to slap over the shock. The seat posts that had a little cut on them so you can get them just a few millimeters lower.
Yeah, that was a real Band-Aid. So while we were making the rocker bikes, if you remember this bike, the SX Trail, I just started prototyping the shock extension on these bikes. And it was successful enough that we moved it back to the 2010 Stump Jumper, which is the one that you had a picture of, which is this bike right here. And you can see your seat post will go right past your shock now, and your shock just goes right around the outside of the seat tube. And it's such a simple idea. And we have a number of patents on that concept. And what I'm particularly proud of is that this design is probably found on half of mountain bikes today. So it was an idea that was very welcomed by people that needed that C-post adjustment. And I really believe it opened the door for dropper posts and command posts, which are so long now. If we were still having interrupted C tubes, we would have never gotten to dropper posts like we have today on everything.
Oh, absolutely. Yeah, 100%. Now, before we kind of we're getting close on time, so we'll need to start wrapping and tapering this conversation a little. But since I have you, Jason and Mick,
Yeah.
you know, we talked about the Demo 9, and we also touched on the 6 bar, sort of the current version of Demo and Enduro, and how the nature of that design allows you to isolate the forces going into the shock versus what the rider's feeling at the axle. That's super exciting to me. Before that, however, we did have the Demo 8, and the Demo 8, the latest version of that race bike, you know, I know it really strikingly from the frame design element, that asymmetric frame design. Beautiful, elegant design. But Jason, I'm curious about the suspension layout on that, and how we went from the previous Demo race bike to that one, where it seems simplified. I see the pivot around the bottom bracket. The location of that horse link is really, really different. And we don't have those additional links. So what was needed? What were you solving for in making such a big change like that?
Are you talking about this bike right here?
That's the one right there.
Yeah, this is really one of my favorites. You know, it's 100% carbon. It's still a 4 bar. The main goal was to lower the center of gravity as low as possible. So I took the chainstay and I moved that bottom bracket pivot lower and lower until it was concentric with the bottom bracket. And then I moved the shock and the upper linkage down as well. The other challenge that guys were having with the earlier bikes was mechanics had trouble getting the shocks in and out of the frame fast enough, because on the pro level, these guys get their shocks tuned quite frequently over the course of a race weekend. And so with the asymmetrical design, you have no problem just popping that shock off the left side, and you don't have to snake it through the frame at all. So it was really all about racing, pushing everything as low as possible and making it fast access for shock tuning.
Makes perfect sense to me. What an elegant solution. Now, you know, those bikes, they're downhill bikes. We're used to seeing coil sprung shocks on downhill bikes. You know, nowadays it's coils almost have had a resurgence, so to speak. So we're seeing coils on enduros. We're seeing riders putting coils on stump jumpers. I've got a Levo behind me, and a lot of people are putting coils on those. Mick, can you share with us about coils today, and why somebody would want a coil versus an air, or vice versa?
Well, I think, you know, earlier in the conversation, I was talking about, you know, why we love air springs in this industry as a whole, and why we as an industry have invested a lot of time getting them to ride well. But generally, the benchmark when you're developing shocks and air spring technology, the benchmark is always going up against a shock, believe it or not. The coil shock has that suppleness. You know, there's no breakaway stiction or friction that's associated like you have with an air spring. You know, all those air seals and stuff are loaded up O-rings and air seals, and you know, they take force to get them to move, and then there's force at the end at the turnaround point. So they bring some friction which into the system that the coil does not. Also, the spring curve, the force curve that you see as you compress an air spring all the way through the travel, even though we've done as an industry with negative springs and volumes, ending volumes to get them to behave like a linear coil spring, they're still not pure linear. And so the thing about a coil if you've ridden them, which I know all of us have, is there's that suppleness that you get out of it, but there's also, there's a predictability because it builds rate in a linear mode. And so as you push into it, you almost can predict how far you're going to go in. You have a better feel, the rider, as you push into it, into the turns. If you really load it, you know you're going to get the same amount of stroke every time. The problem with air springs can be, they have a little bit of a nose, a knee, a slope, and then a hook at the end. And so you can be pushing into right before the knee and put a fair amount of force into it, get over the knee, and then find that same force you overstroke or you get more stroke than what you're thinking. So when it really comes to really pounding the bike, pushing into it, and doing everything else, that pure linear rate can be really predictable for the good guys that are pushing against it and looking for that feedback that comes back through the pedals.
Right.
That said, they're heavier, and then getting that spring rate, you might end up with 4 springs sitting on the top of your toolbox that you never use again. Once you dial, but
yeah, I've been there.
But once you do that, then you're dialed. Yeah.
Sure. Now, I'd like to quickly break it down for people who may not speak Mick. So I heard things like that I'm sure don't mean to you what they mean to most people. So we're talking about a nose, a knee, a slope, and a hook. So for the people who may not be as versed in shock speak, the nose, when you talk about a nose, what that feels like to a rider, that's going to be that initial point of impact, or small bump, chatter, right? The nose is going to be like a resistance to that initial breakaway force into the travel. Is that correct?
Yeah, exactly. When we look at the spring force, the nose is the amount of force it takes to get that spring move. And so when we measure these on the dyno, you'll see the initial spring rate, once you apply force to get it to move. And so we try to manipulate that, but we do manipulate it with a negative spring. But what you will get is, once you get off the negative spring, you get this knee. That's where the curve will bend a little bit, and then you're just compressing the main volume of the air spring. So that bend point is what we call the knee, and then we get the general slope across the middle of the spring of the train, which is just compressing the main air piston in the chamber. And then the ending volume, how much volume we leave at the end of the stroke, determines how the hook is. So if it's a
hook, it's going to be the resistance.
Bottom out easy. Okay. Exactly. So when you look at the curves, and I apologize for that because we have the knee, the slope, and the hook, and those are what we look at, and that's like.
Yeah. And now knee and slope, that may also be referred to as mid-stroke support, or a hammocking or wallowing sensation.
Exactly. That hammock, you're exactly right there, Jared. So that the hammock is, if the slope is too flat in the middle, that's that hammock that it's often referenced to. So you need enough rise in that slope so that you don't overstroke in the middle, and it's that mid-stroke support that you need to have the control it's going to do.
Right.
There's nothing on some of these early long travel designs we were talking about earlier. They were famous for that, especially. I mean, you push into the forehead, and all of a sudden, boom! It would you'd get over that knee, and there was a slope in the middle, and then there was just a hook at the end, and you would just give all that travel away for free. It's like the trail event did not warrant the amount of travel that you used because those spring curves were pretty.
I unfortunately recall that sensation very well. Yeah, it seemed that we have had a few transitional years that kind of bookend different periods of time where what was happening with air springs and suspension wasn't totally aligned across the board with what frame engineers were designing for. And so we had kinematics that didn't really feel like they spoke the same language as what the spring curves were doing. So I imagine that, with the situation that you two have now, is a wonderful partnership, because from the very early stages of conception, when you're taking on a new project, you are sort of hyper aligned in making sure that you're both coming to the table with products that are essentially speaking the same language. Is that accurate?
That's very accurate. And
Yeah,
that's it in a
completely.
nutshell.
Okay. Yeah. Well, on that bombshell, talking about being hyper aligned in the whole program, we were right there on time. So thank you both very much for hopping
Sure.
on and talking FSR and where we've been, where we are today, and ideally taking all of this and giving some uh, awareness to where we are, so we can think about where we're going in the future.
Right on.
I'm excited about it.
You bet.
Yeah. So thanks again. You guys both have a great rest of your day.
No problem.
All right. Thanks,
Thanks.
Gary.
We'll see ya.